as far as I know, there will be a raffle later for a tablet, looking more or less like this. But there is one major difference. This tablet has a Type-C connector. And Type-C has actually arrived. There are products with, or from almost every product category shipping. Multiple products are announced but not shipping yet. There are rumors that there is actually a major issue getting connectors because some big customers are buying them all. Let's have a quick overview of the connector. It's one symmetrical cable. As you can see, same connector both ends, and you can plug it in either way. There is no orientation and no direction. Also, it's a small and robust connector. If you could fit a micro B connector on your product, you can easily mechanically rework it for this. Also, it has got a much improved EMI RFI performance, and it is expandable, which we'll get back to. So the key to this, to make it flippable and reversible, is X and Y axis symmetry. So I haven't got the animation here, but you can see you've got your, this is the standard connector color-coded with different signals. If you flip it 180 degrees, it still matches up. With a couple of small changes. TX1 and TX2 are now opposite each other. Same for RX. And sideband use and CC, which has a slight implementation aspect, because you've now got 4 different paths through your cable, depending on which way it is at either end. And you'll actually have to switch your signals to go through the active cable or the active pair. You can do that using a multiplexer or switch, or you can do it natively in the chipset. This is first generation, 0 generation solutions, and this is what you will eventually have in products when they're all optimized for Type-C. So building a Type-C product, a lot of people started out like this. They read the spec, we connect the spec, and that's it. What they didn't realize is that all of this is vital. You might not be using all of it, you might not need to understand all of it, but you have to be aware of it. If not, it will literally sink your project. By the way, in the middle of this is the Type-C file. So we'll get back to the Type-C file. Let's just look at some of the magic for Type-C first. The host, okay, remember, there is no A, there is no B end. You don't have a host device role based on the cable orientation. So it's the device itself that has to say, I'm host, I'm device. So the host says, I'm a host by having a pull-up. The device says, I'm a device by having a pull-down. And for portable devices, that's very useful, because a pull-down doesn't require any power. You can have the pull-down there. You don't even have to pull it to a voltage. You just connect it to ground. That's it. Then, when the device connects to a host, the pull-down is stronger than the weak pull-up, and you're done. The host knows that there is a device. And then the host can enable VBus, because unlike standard USB, remember, you can connect 2 hosts together now because they have the same connector and you have a symmetrical cable. Connecting 2 hosts together connects 2 power supplies together, unless you're careful and you know that when one power supply wins, the other loses. So we don't want that to happen. What happened here? Oh, okay. Let me see. Can we get it back in presentation mode? Because it went out of presentation mode, I think. Yeah, there we go. So that's the quite simple magic behind Type-C. There is also some other magic, like since there is only one wire in the cable, you actually know the orientation depending on whether it's one or the other pull up that is pulled down. And then comes the slide that we could spend an hour on discussing, but we won't do that. I'll be quick. Basically, keep in mind that with classic USB, you have D plus, D minus. Everything was multiplexed on D plus, D minus. High-speed USB was multiplexed on the go, battery charging, everything. So you literally had to implement it in the PHY. You couldn't successfully divide and conquer. With Type-C, you've got your CC function, which is a completely separate function that has its own 2 pins on the connector. And you've got all your design choices. Do you put your controller in as a finite state machine in hardware? Do you have a programmable state machine? Do you have it in pure software? Do you have it in the application CPU? Or do you have a small embedded micro somewhere that is more suited to doing this? So you have an enormous amount of implementation options, and that's not good when your business is IP, because it's very difficult to define IP for that. So at the moment, most companies will actually implement this in the way that they find most suited for each and every product, which will be different, because if you're doing something that has a power management IC, well, that's obviously where you should put your 3 amp power switches, right? So, but again, back to the Type-C, the optimized Type-C PHY for doing the data path. If you have a PHY that basically routes directly to the connector with 2 lanes that has a direct drop down of D plus, D minus, you will have the same jitter tolerance, the same signal quality eye height as a single PHY, which is extremely important when you go to USB 3.1 and 10G. You can't afford to lose a dB, 1.5 dB in the switch that first generation USB 3.0 solutions do. And you can have expandability. You don't have to change your SoC. You just change your external circuitry, support circuitry, to adapt it to whatever functionality you need with that SoC. So this kind of optimized Type-C PHY is a really important building block for making sure you can build an SoC that isn't obsolete the moment it's taped out, because you didn't think of everything that Type-C means to other people who want to build a product. I said the Type-C connector is expandable. Let's have a quick look at some of the expandability here. There is something called the alternate mode, and you've got 10 pins on the connector that's actually available for alternate modes and can be reassigned. As of today, DisplayPort, MHL and Super MHL are defined. A few days ago, they introduced Thunderbolt 3 using the Type-C connector, and by definition, I think Thunderbolt is an alternate mode, although I haven't seen the spec yet. So this is what happens. USB only. The 4 lanes on the connector is used like this or that, depending on whether it's flipped or not. And in DisplayPort mode, yes, you'll have the same. You actually have to move it around depending on how it's flipped, because your adapter cable at the other end doesn't have the flippability, so you have to do the flip on the Type-C side. And then if you run both, you'll have this and this. So you see, this gets rather complex, especially when you consider that you can also have 4 DisplayPort lanes in this, that you might also have to support. And I'll tell you, the Type-C spec was released a while ago, and it's been updated, and it's going to be updated again. Same with some of the alternate modes, because implementation beats the paper that the spec is written on. So if we just have a look at how it looks like, it used to be very simple. You had a USB software stack, a controller, and a PHY, and that's it. And according to the OC model, you only had communication up and down. When you introduce the alternate modes, you get all these side protocols. And I should really have had an animation here with some octopus that would sit there with their arms everywhere, because for Type C you will have communication not up and down, you will have it from the top directly to the bottom across between the different protocols and controllers. It's non-trivial. What is certain is that, let's look at this part. Having the switch and the PHYs, the world needs to go to this to have an alternate mode combo PHY that can do either or. That'll solve it. And that's the end.
Well, what types of products benefit using Type C?
Well, every product that has the user inserting the cable more than once, I'd say.
All right.
So one of the big, I mean, we've been playing around with Type C, and I have to admit I like it. It really works. You plug it in. You don't have to. You keep in mind that standard USB is the three-try connector, because first you look at it. So okay, this should work. No, it didn't. Flip it round. Definitely didn't, and then back. So even when you observe it, it still takes 3 times. No, you just.
So one, two.
Yeah. You don't have to do that.
Go ahead.
Is there an adapter to the standard USB?
But if it's
An adapter.
no, this is a standard straight through Type C to Type C.
No. Let's say you want to connect this to a standard USB.
Then you use these adapter cables. They're already available. So you got Type C on one end
I see.
and standard A here.
Okay.
And you can also have standard B.
Okay. And where would you find more information on if someone is designing their next SoC using Type C? How would they find that information?
We have published a webinar
Okay.
with some hints to how you adopt an existing design and what to look for when doing the next. There is also a presentation we did at the Lindley Mobile, which should be accessible to people. And of course, always contact me or anyone else that you know in Synopsys.
Contact Mort or
contact you.
ChipEstimate.com. You just go, yes,
Yeah.
and we'll connect you.
Yeah.
We're like Match.com for chip
Yeah,
designers.
you see, we match really nicely.
All right.
Both got beards.
Thank you so much. I want you to stick around because I want you to draw the winning ticket.